こんにちは。株倉応援チャンネルにようこそ。今回の動画は AI 半導体メーカー、エヌビディアの開発者会議 GTC2025 よりジェンセンファン CEO の基調演説の様子を翻訳字幕付きでお届けします。このチャンネルは主に海外の CEO のインタビュー動画やカンファレンスの様子を日本語字幕付きでお届けする切り抜きチャンネルです。まだの方はぜひチャンネル登録をお願いします。それじゃあ動画を楽しんでってね。
I love what we do. I love even more what you do with it. And one of the things that most touch me, in my 33 years doing this, one scientist said to me, Jensen, because of your work, I can do my life's work in my lifetime. And boy, if that doesn't touch you, well, you got to be a corpse. So this is all about you guys. Thank you. All right, so we're going to talk about AI. But you know, AI started in the cloud. It started in the cloud for a good reason, because it turns out that AI needs infrastructure. It's machine learning. If the science says machine learning, then you need a machine to do the science. And so machine learning requires infrastructure, and the cloud data centers had infrastructure. They also have extraordinary computer science, extraordinary research, the perfect circumstance for AI to take off in the cloud and the CSPs. But that's not where AI is limited to. AI will go everywhere. And we're going to talk about AI in a lot of different ways. And the cloud service providers, of course, they like our leading edge technology. They like the fact that we have full stack, because accelerated computing, as you know, as I was explaining earlier, is not about the chip. It's not even just the chip in the library, the programming model. It's the chip, the programming model, and a whole bunch of software that goes on top of it. That entire stack is incredibly complex. Each one of those layers, each one of those libraries is essentially like SQL. SQL, as you know, is called in-storage computing. It was the big revolution of computation by IBM. SQL is one library, just imagine. I just showed you a whole bunch of them. And in the case of AI, there's a whole bunch more. So the stack is complicated. They also love the fact that CSPs love that NVIDIA CUDA developers are CSP customers, because in the final analysis, they're building infrastructure for the world to use. And so the rich developer ecosystem is really valued and really deeply appreciated. Well, now that we're going to take AI out to the rest of the world has different system configurations, operating environment differences, domain-specific library differences, usage differences. And so AI, as it translates to enterprise IT, as it translates to manufacturing, as it translates to robotics or self-driving cars, or even companies that are starting GPU clouds. There's a whole bunch of companies, maybe 20 of them, who started during the NVIDIA time. And what they do is just one thing. They host GPUs. They call themselves GPU clouds. And one of our great partners, CoreWeave, is in the process of going public, and we're super proud of them. And so GPU clouds, they have their own requirements. But one of the areas that I'm super excited about is edge. And today we announced today that Cisco, NVIDIA, T-Mobile, the largest telecommunications company in the world, Cerberus ODC, are going to build a full stack for radio networks here in the United States. And that's going to be the second stack. So that this current stack we're announcing today will put AI into the edge. Remember, $100 billion of the world's capital investments each year is in the radio networks and all of the data centers provisioning for communications. In the future, there is no question in my mind That's going to be accelerated computing infused with AI. AI will do a far, far better job adapting the radio signals, the massive MIMOs, to the changing environments and the traffic conditions. Of course it would. Of course we would use reinforcement learning to do that. Of course MIMO is essentially one giant radio robot. Of course it is. And so we will, of course, provide for those capabilities. Of course, AI could revolutionize communications. You know, when I call home, you don't have to say but that few words because my wife knows where I work, what that condition's like. Conversation carries on from yesterday. She kind of remembers what I like, don't like. And oftentimes, just a few words, you communicated a whole bunch. The reason for that is because of context and human prior knowledge. Well, combining those capabilities could revolutionize communications. Look what it's doing for video processing. Look what I just described earlier in 3D graphics. And so, of course, we're going to do the same for Edge. So I'm super excited about the announcement that we made today. T-Mobile, Cisco, NVIDIA, Cerberus ODC are going to build a full stack. Well, AI is going to go into every industry. That's just one. One of the earliest industries that AI went into was autonomous vehicles. The moment I saw AlexNet, and we've been working on computer vision for a long time, the moment I saw AlexNet was such an inspiring moment, such an exciting moment. It caused us to decide to go all in on building self-driving cars. So we've been working on self-driving cars now for over a decade. We build technology that almost every single self-driving car company uses. It could be either in the data center. For example, Tesla uses lots of NVIDIA GPUs in the data center. It could be in the data center or the car. Waymo and Wave uses NVIDIA computers in data centers as well as the car. It could be just in the car. It's very rare, but sometimes it's just in the car. Or they use all of our software in addition. We work with the car industry however the car industry would like us to work with them. We build all three computers, the training computer, the simulation computer, and the robotics computer, the self-driving car computer, all the software stack that sits on top of it, models and algorithms, just as we do with all of the other industries that I've demonstrated. And so today, I'm super excited to announce that GM has selected NVIDIA to partner with them to build their future self-driving car fleet. The time for autonomous vehicles has arrived, and we're looking forward to building with GM AI in all three areas. AI for manufacturing, so they can revolutionize the way they manufacture. AI for enterprise, so they can revolutionize the way they work, design cars and simulate cars, and then also AI for in the car. So AI infrastructure for GM, partnering with GM, and building with GM their AI. So I'm super excited about that. One of the areas that I'm deeply proud of, and it rarely gets any attention, is safety, automotive safety. It's called HALOS. In our company, it's called HALOS. Safety requires technology from silicon to systems, the system software, the algorithms, the methodologies, everything from diversity to ensuring diversity, monitoring and transparency, explainability. All of these different philosophies have to be deeply ingrained into every single part of how you develop the system and the software. We're the first company in the world, I believe, to have every line of code safety assessed. 7 million lines of code safety assessed. Our chip, our system software, and our algorithms are safety assessed by third parties that crawl through every line of code to ensure that it is designed to ensure diversity, transparency, and explainability. We also have followed over 1,000 patents. And during this GTC, and I really encourage you to do so, is to go spend time in the Halos workshop so that you could see all of the different things that comes together to ensure that cars of the future are going to be safe as well as autonomous. And so this is something I'm very proud of. It rarely gets any attention. And so I thought I would spend the extra time this time to talk about that. Okay, NVIDIA Halos. All of you have seen cars drive by themselves. The Waymo robo-taxis are incredible. But we made a video to share with you some of the technology we use to solve the problems of data and training and diversity so that we could use the magic of AI to go create AI. Let's take a look.
NVIDIA is accelerating AI development for AVs with Omniverse and Cosmos. Cosmos prediction and reasoning capabilities support AI-first AV systems that are end-to-end trainable with new methods of development. Model distillation, closed-loop training, and synthetic data generation. First, model distillation. Adapted as a policy model, Cosmos's driving knowledge transfers from a slower, intelligent teacher to a smaller, faster student inferenced in the car. The teacher's policy model demonstrates the optimal trajectory, followed by the student model learning through iterations, until it performs at nearly the same level as the teacher. The distillation process bootstraps a policy model, but complex scenarios require further tuning. Closed-loop training enables fine-tuning of policy models. Log data is turned into 3D scenes for driving closed-loop in physics-based simulation using Omniverse neural reconstruction. Variations of these scenes are created to test a model's trajectory generation capabilities. Cosmos Behavior Evaluator can then score the generated driving behavior to measure model performance. Newly generated scenarios and their evaluation create a large dataset for closed-loop training, helping AVs navigate complex scenarios more robustly. Last, 3D synthetic data generation enhances AVs' adaptability to diverse environments. From log data, Omniverse builds detailed 4D driving environments by fusing maps and images, and generates a digital twin of the real world, including segmentation, to guide Cosmos by classifying each pixel. Cosmos then scales the training data by generating accurate and diverse scenarios, closing the sim-to-real gap. Omniverse and Cosmos enable AVs to learn, adapt, and drive intelligently, advancing safer mobility.
今回の動画はここまで。みんなチャンネル登録絶対に忘れないでね。それじゃあまた今度。